Hey guys, welcome back. One more set of reactions. Chemistry is full of reactions. This particular video is going to focus on combustion reactions. In this video, I'm going to tell you what a combustion reaction is, and we'll practice balancing some combustion reaction equations. There's a little trick to it, and like the polyatomic ions that you don't split up, combustion reactions need to be handled in a somewhat specific way. So let's get started. Okay, so a combustion reaction is a chemical change in which an element or compound reacts with oxygen, and usually you're producing energy in the form of heat and light. So basically you're burning something. That's a very simple way of writing it. A combustion reaction is a chemical change. Remember, there were physical changes and chemical changes. This is a chemical change in which an element, or possibly a compound, reacts with oxygen, often producing energy in the form of heat and light. It always involves oxygen. And so you could not really set up a combustion reaction in outer space. So let's say you went to Mars and you decided, hey, I think I'm going to grill on Mars. So this video is being filmed in 2025. Okay, you get on Mars. As of now, there ain't no oxygen up there, folks. So you are not going to be able to set up a combustion reaction, and always involves oxygen as a reactant. A reactant is what is on the left side of the arrow. Products are on the right side of the arrow. Now, for our purposes, you need to remember that the other reactant that you will inevitably be looking at, especially in a general chem class or starting out chemistry class, is going to be a hydrocarbon. They are compounds made up of carbon and hydrogen. Now, here's the deal, folks. You might be able to also get possibly oxygen in things like alcohols. Okay, so hydrocarbons are primarily compounds made up of carbon and hydrogen, but you could also have an oxygen in there. So if you look at gasoline is a hydrocarbon. If you look at propane is a hydrocarbon, primarily made up of carbon and hydrogens. But you could also have something like Purell, which is ethyl alcohol. It is an alcohol. It also burns. Methane would be a hydrocarbon. Okay, and so it's a class of compounds. Methane would be part of that class, and it is a hydrocarbon. And you can also classify compounds in chemistry in multiple ways. So it is a hydrocarbon, and it is also an alkane. Okay, these are hydrocarbons that contain explicitly carbon and hydrogen. You also need to be able to predict the products of a combustion reaction. So the complete combustion of a hydrocarbon produces carbon dioxide and water. The reactants are going to be oxygen for sure. You're going to have some hydrocarbon with there, and it's going to produce carbon dioxide and water. Imagine for a second you're burning methane, and you're burning it in the presence of oxygen, and it's going to produce carbon dioxide plus water. If for some reason you have a limited amount of oxygen, so if you don't have the required amount of oxygen, so you've got less oxygen than you need, the combustion will not be complete, and you'll end up forming soot, carbon, and other toxic compounds like carbon monoxide will be produced. If incomplete combustion, due to a lack of oxygen, you will form carbon deposits. So it's basically soot. It's like this very fine black powder that you'll see on pans and on test tubes. That's what's happening. You will form carbon, soot, and possibly carbon monoxide. But we're primarily talking about complete combustion. I'm going to show you how to balance combustion reactions. The important thing is to, as always, remember you cannot change the subscripts. And we're going to use methane and oxygen. And what are the products, guys? Come on. You got to stay with me. Oi, you paying attention? I know you are. You? Yes, no? I hope you are. Super important that you pay attention. Dylan, I know you're paying attention. So methane plus oxygen, they react, they burn. So methane burns, and you get carbon dioxide plus water. Okay, so that is the product. Oxygen is showing up here, here, and here. So oxygen shows up in three places. In this equation. And so when that happens, if it shows up in three or more, well, more than two places, so 3, 4 places, you always balance it last. Oxygen shows up in 3 places in this equation, so balance it last. We are burning methane, so that is CH4. And guys, you should have seen this molecule at this point. CH4 is a tetrahedral molecule. It is a molecular compound, carbon and hydrogen, and you're burning it in the presence of oxygen. So in order for this to burn, you know it's a combustion reaction. One of the reactants has to be oxygen, and it's going to form carbon dioxide plus water. These are the products. So the reactants always equal the products in terms of mass and the number of atoms. So we're going to try and balance this. So carbon, hydrogen, oxygen, you always list the elements, and you want to list them in the same order as you did over here. Oxygen shows up here, here, and here. In a situation where you have an element showing up in multiple places, you want to make sure that element is last on this list. It needs to show up at the very end. Carbon is 1, hydrogen is 4, oxygen is 2. Right here, carbon is 1, hydrogen is 2. I am writing the oxygen, it's 3, 2 plus 1, but I'm writing it as 2 plus 1. And the reason I'm writing it like so is because there's 1 over here. That 1 is this. This 2 is written like so. Now, obviously, these are not balanced. You can see that. But it's important that you keep these separated because it'll make balancing it a breeze. So here we go. 1 carbon. So far, so good. This looks good to me. This part, check. The hydrogen, we got 4 here. We've got 2 here. So we're going to need to multiply this by 2. So this becomes 4. Looking good. This 2 is going to go over here. You can only change the coefficient. You can never change the subscript. So this 2 goes over here. Hydrogen is 4. You're all set. But this 2 also applies to this oxygen. So now all of a sudden, this 2, if you multiply 1 by 2, this gets multiplied by 2. And then this is equal to 2. And this needs to come down here. So we're going to cut this out and make it a 2. When we do that, you can add these together, and now you have, instead of 3, you have 4. So that 2 made this oxygen a 2. So you got 2 atoms there, or 2 moles there. And that was brought down here. So now your grand total for oxygens on the product side just became 4. In order for you to make this a 4, you multiply this by 2. Boom. And you're going to run this all the way up here. That's the coefficient, and you get 2. So the ratio for methane, when you burn methane, the ratio is going to be 1 methane, 2 oxygen. So this is where the 1 comes from. This 2 represents the oxygens. This represents the methane. And this reacts to give you 1 part carbon dioxide and 2 parts or 2 moles of water. That is the ratio when you burn methane in oxygen. This is a hydrocarbon. This is oxygen. This is a hydrocarbon burning in oxygen. These are the reactants, and it gives you carbon dioxide and water. So Grace, I'm hoping this makes sense, and let me know if it doesn't. Example number 2. Voila. Hey! Pop your phone away, guys. Focus, okay? You need to be able to do this. This is a little bit tricky. Propane, this is what you have on a grill, plus oxygen gives you carbon dioxide plus water. Formula for propane is C3H8 plus oxygen reacts to give you carbon dioxide plus water. And you know it's a combustion reaction because oxygen is one of the reactants, carbon dioxide and water are the products. Oxygen is showing up in 3 spots. It's showing up here, showing up here, and showing up here. Therefore, oxygen needs to be the very last one on the list when you're balancing. Carbon, hydrogen on top, same order on the right-hand side, carbon, hydrogen. So we're going to start plopping these numbers in. So there's 3 carbons, there are 8 hydrogens, there are 2 oxygens. On the right-hand side, there is 1 carbon, there are 2 hydrogens right here, and there's 2 oxygens here, plus 1 oxygen from there. Okay, remember, even though it's not written, there's a 1 over there. This 2 applies to this 2. This 1 applies to this. It's important to keep them separate. It'll make balancing it a lot easier. Okay, so we're going to need 3 carbons here because we only have 1. So we're going to multiply this by 3. This is balanced. You're going to take this 3 and run it up here as a coefficient. One more time, guys, for the nth time, you cannot change these numbers to balance an equation, the subscripts. The only place you can change the number is in the coefficient. You can never, let me repeat, never change these subscripts. These are always set in stone. The 3 carbons work here, but now you've taken this 3 and you've multiplied the oxygen by it as well. So it's 2 multiplied by 3. So we're going to end up right here with 6. So this just became 6. So we've got 6 oxygens over here. Okay, so the carbons are good. Let's move on to the hydrogens now. We have 8 hydrogens over here. We have 2 here. If you multiply that by 4, you'll end up with 8. So that part's good. We got 8 here. So that 4 is going to make its way all the way up here. So we've got 4 molecules of water, or 4 moles of water being produced. This 4 applies to the hydrogen, so that part's good. But it turns out it also applies to this oxygen. So it's 1 multiplied by 4, which is equal to 4. We're going to cut the 1 out and make it a 4. So now you've got 6 plus 4 is equal to 10. Now you need 10 oxygens here. You're going to multiply this by 5. That will give you 10. Circle the multiplication factor, which is 5. And run it up here as a coefficient. So now you've got 1 mole of propane. It requires 5 moles of oxygen to burn appropriately, complete combustion. It's going to give you 3 moles of carbon dioxide and 4 moles of water. 1 mole propane. Okay, that's going to react with 5 moles oxygen gas. And that's going to give you 3 moles carbon dioxide. Plus, it's going to give you 4 moles of water. And instead of a plus, I'm just going to put it as a ratio. So 1 mole propane to 5 moles oxygen is going to give you 3 moles carbon dioxide and 4 moles of water. Those are the ratios. A couple of things. I did not write the states of matter, so let me go ahead and do that. This was a gas. This is a gas. This is a gas. And the water is water vapor, a gas. Same applies here, guys. This is a gas. This is a gas. And the water vapor is a gas. So there you have it. Combustion reaction for you, and I'll see you in the next video. Bye.